Hello once again, college algebra students. Those of you watching from Avon High School, welcome to the video covering section 14.2, investigating the graphs and the equations of exponential functions. If you're watching this video from outside of Avon, just to kind of give you a little bit of insight, this is day 2 of this particular lesson, where the first day was kind of dealt with looking at both equations and graphs of exponential functions and classifying them into a couple of different groups. And the main idea of the classification was to decide whether or not we had growth and decay. What we're going to do with this is just go into a lot more detail about how you can tell the difference between growth and decay. Now I'm going to go ahead and move down here to the bottom part of the first page of these notes. And I know that in class we filled this out yesterday, but if you guys, my students here with me today, would bear with, I'm going to go ahead and run through this again just very quickly, and then you can just make sure that your notes packet has the correct answers. So the directions were the following. All exponential functions have the equation of this form, and I'm going to highlight this form. This is a very powerful, important form. It's one form that you certainly want to memorize. It's got a lot of letters of the alphabet in it. Now it says that the b value has to be positive. That is a given. That always has to be the case. And that b value can never be equal to 1. And in class we talked about if this b value were 1, then this equation takes on a very simplified existence, because if the b value is 1, then 1 to the x minus c is really not there, and you just have a plus d, which is a constant. And if f of x is a plus d, then you have a straight line, don't you? A horizontal line, in fact. And that's not going to be an exponential function. So b will never be 1. Now it says for each of the following exponential functions, we are being asked to identify the indicated values and the information to complete the table. All right, so it's just as easy as extracting the positions a, b, c, and d. So for our first problem, we notice that the a value is going to be the number 1, because there is no a in front of our base. The b value, which is the base, the thing that's being raised to the power, is 3/2. And then the c value, this was a little tricky. You guys did a good job of this in class. But in class, I think we said that you're just going to solve that exponent equal to 0. And every time, that's going to reveal what the value of c is. So in this case, the c would be 2. The d value is just simply the constant at the very end, -2. Now, we were doing a lot of this yesterday, but what we never got to is what these numbers meant. If a is such and such, what does that say about the graph? If d is such and such, what does that say about the graph? And that's what the importance of today is all about. Also, in class yesterday, let me rephrase that. Your teacher really didn't do a very good job of talking about this 4th, 5th column, right? The reflective column. I've got the answer for you now, right? Here's how we're going to think about this last column. You have to trust me. I have sketched each of these graphs, and I don't want to run through the process of sketching each one again, okay? But I will sketch just the first one. So I'm going to switch over to the calculator software, and you guys can just watch. You don't need to type this in. But I'm going to type in that first expression, which was, what, 2/3? Is that the base, 2/3? Remember, even if you don't put I'm sorry, it's not 2/3. You guys didn't tell me. It's 3/2, right? 3/2. And if you raise that to the -x plus 2 power, it automatically puts parentheses around it. Subtract 2, and boom, there's the curve. For those of you watching outside of Avon, we're using the TI Inspire CX2 or premium software for this particular problem. So that's what this graph looks like. All right, so all I wanted to do is just maybe give a crude sketch of this graph. In other words, I'll just kind of draw what I saw in my calculator like this. Okay? Now, what type of reflection, x-axis, y-axis, or both, is indicated by this particular equation? And that's the part that we were a little confused about yesterday. Well, I'm going to tell you, the answer is y-axis. Now, does anybody in here know why this is a y-axis symmetry? It has to do with maybe something, I don't know. We'll talk about it. To determine what kind of symmetry you have, I'm going to get rid of this graph, and I'm going to do this. I'm going to graph one of the most simplest exponential functions in the world, y equal 2 to the x, right? Is that an exponential function by definition? Basically, if you have an x as an exponent, you have an exponential function. That's why they're called that. So there's what 2 to the x looks like. Okay? Now, in this particular problem, what do you notice hanging out in front of the exponent's x variable? A negative sign, right? So to replicate that, I'm going to sketch a graph of, I'm going to sketch a graph of 2, let's try that again, 2 raised to the negative x, to sort of replicate that negative sign's existence. And that's what I have. What kind of symmetry is that, you guys? Y-axis symmetry. So that's how you can tell, you guys. It's that simple. If there's a negative sign in front of the x exponent, you've got y-axis symmetry. Do you want to take a stab in the dark as to how you could tell if there is x-axis symmetry? What if there is a negative in front of the base? Compare the blue graph with the black graph. Is that x-axis symmetry? So that's all you're looking for. It's that simple. So if we return to the document, we can see that y-axis symmetry exists because of the negative right there. Okay? Now I'm going to go through these other boxes very, very quickly. In number 2, we had the a value of being -1. Now, I know that students might want to look at this and say, no, the a value would be nothing, and the b value would be -3. But that can't be true, right? You can't have a b that's negative. So the b is actually +3. Now, the c, remember, is taking the exponent, setting it equal to 1, and solving. And then, boom, we get the answer of 1. And then the d value is probably one of the easiest to find. Okay. Now, I'm not going to sketch a graph of this, but I'm going to ask my students. I'm going to put you on the spot. You're on national television. Okay, it's YouTube. Close. What kind of symmetry do you think is happening with problem 2? Sam? He's exactly right. X-axis symmetry. And the reason is because of the negative sign in front of the a. So -a, x-axis symmetry, negative sign in front of the x, y-axis symmetry. All right, let's do 3 very quickly. The value of a that we saw in class yesterday was 2. The b is 2/3. The c value, I know some of you are like, oh, I know it's 1. I can tell it's 1. You're right, it's 1. And the d value is -2. What do you guys think about the symmetry? Is there any? There's none. Okay. Now, it might be really, really easy for you guys sitting there to say, what's the big deal about the reflectiveness? And again, I'm so bad about using the word symmetry. I should not say symmetry. It should be the reflective nature. So what's the big deal about whether or not there's a reflection? That's what's going to come into play at the end of class today. All right, so the final column is not something to kind of be ignored. All right, let's look at 4. We did this one in class yesterday where we said A was -1. The B would be 2/3. Solving for the C, we would end up with -x is -2, so that means x is +2, so that means the C is 2, and the D, of course, is 3. What do you guys think about the reflective nature of this graph? And you can just shout it out. Both of them, very good. I suppose if you wrote both, that would be sufficient, but these are the only 2 kinds of reflections that we're asking about. Yeah, you have both the negative here and the negative here. Now, what that's going to mean later on is that those 2 things essentially cancel each other out. And if you guys had to guess, based on our conversation yesterday, would this be growth or decay? Do you remember? And if you don't remember, it's okay, because we're going to go over it again. It is decay. But do you realize that if it only had one of these reflective natures, it turns it into the other one, growth, even though it has a fractional value for b less than 1. And that's where it can get tricky. Okay. Final one here, very, very, very fast. We end up with an a of -3, a b of 1/2. X is going to be equal to -1, so that means -1 is C. Of course, -1 is also D. What kind of symmetry does this problem have? Because there's a negative in front, that makes y-axis symmetry, right? Or y-axis reflectiveness, I should say. I meant X. Sorry. You're right. X-axis. It's just like this guy. I'm just making sure you're awake. Right? I mean, I think it makes sense because when the whole function takes on a negative value, that just means any point that was above the x-axis is now reflected below. So the reflection is definitely around the x-axis. All right, so that's kind of catching us up to where we mildly left off yesterday. Okay, now this next page of the notes for my students, we did a card sort yesterday that had each of these 12 functions on a card, and we had to kind of classify them into different groups. We're going to refer back to this page quite a bit. Even in the video, you're going to see me turn back to this page. For the purpose of this video, I will put a link in YouTube that will give you access to this particular document if you're watching this outside of Avon. Okay, now we are going to go ahead and move on to this next page. And I believe this is new. I don't think we filled this one out, right? And then this page, basically what it asks is, it says, well, in the boxes below, let's identify how the values of a and d in this equation seem to affect the function. How do the values of a and d affect the function? And we have a kind of giving us two different sort of classifications, two different reasons, and then there must be three different reasons that d has an impact. Okay, so here's where a is. Can somebody tell me what are the two different things or two different values that a could take on? A could be either this kind of a number or this kind of a number. What am I talking about? Any guesses? Take a guess. Boom. That's really your options. So we'll start this by saying if a is a negative number, and then we can start this by saying if a is a positive number. Okay? Now, wait a minute. Is anybody thinking, what? Couldn't a be 0? I mean, isn't 0 a number? Well, let's think about that. What would happen if a was 0? Yeah, this whole thing is wiped out. This is no longer an exponential function, and we're not even having this conversation, right? So a would never be equal to 0. Okay? Now, what effect does A's sign have? It may not be real clear. So guys, what I am going to do is I'm going to go back to my graph. And I am going to change each of these. I'm going to get rid of these. And I'm going to do something kind of interesting here. You know the effect it has? Awesome. I'm going to call on you in a little bit then, okay? I'm going to do this. I'm going to type in A times, and then I'm going to use a standard B like 2 raised to the x power. And then I'm going to say plus B, or I'm sorry, plus D. Now, if I do that, the calculator is going to say, hey, what are you doing with this A and D? And I want to make sliders. I want these to be things that I can change. So I'm going to say, yep, make both sliders out of A and D. So there's my 2 slider settings. I just want to put this somewhere out of the way. In fact, you know what I want to do? I want to make these small. I'm going to minimize each of these sliders. That way they don't take up nearly as much room. Okay. Minimize you as well. Okay. I don't mind them being horizontal. That's totally okay. Whoops. Okay. Trying to move. Excuse me. Yep, we're live here. There. I'm going to move them in this lower corner here so that they are not going to get in the way of the graph. All right. Now, here's what I want you to do. I want you looking at the D. Watch the D as I change it, and then look at the graph each time I change it. I'm going to take D all the way up to 5. Okay. Let's take it back down to where it was at 1. And now I want to lower the value of D. Can somebody tell me what feature of the graph is present by the value of D? Sam? I believe it's the horizontal asymptote. Now, I think on the TI Inspire, we might be able to be really creative with that. So I'm going to see if I can go into my graph and graph another line, but I want this line to move. So maybe I could call it F2 equal D, and it would sort of move dynamically. See what I'm saying? And if this is supposed to be a horizontal asymptote, don't we typically graph asymptotes with dashed lines? Well, let's make that happen. I'll just change its attributes to be dashed. Now we got something that looks more like an asymptote. Okay. Now, everybody in the room understands the role of D. Let's talk about the role of A now, because that's what we're supposed to figure out. The role of A, if A is a positive number, look at the graph. Okay, I don't know about you, but I don't see a whole lot of stuff changing. It just gets a little steeper, okay? Now let's let A be negative. Now remember, A can't be 0. We already said that. Now A is negative. What role does A's sign play? To an extent, it is true about growth and decay, but I'm going to throw a curveball at you here in a little bit. In other words, I could have a negative A value, and if I go into this graph, even though my A is negative, I can trick you and turn this into growth, even though it's clearly the fact that A is still negative. So that's where we got to be super careful. Now I'm going to change my function back so it has a positive exponent now. Don't think of it so much as what the curve looks like, think about where the curve is located. Liv? That's what we want. It tells you whether or not the curve is above or below the horizontal asymptote. That's all we have to say. So we'll go back to the document, and we see that if A is negative, then we don't have to say the function. We could just say if A is negative, f of x is below the horizontal asymptote. And we're going to abbreviate. We're going to call horizontal asymptote HA. All right, we're not messing around with that. If A is positive, that means that f of x is above the horizontal asymptote. Okay? So far, so good. Now, what is the value of D? What role is he playing in the problem? Well, I think that we've pretty much determined that D discloses what? D determines the location of what? The horizontal asymptote, right? Now, if you forgot that, no big deal. I can go back to the document here, and you can see that in this case, D is a value of 2, right, by my slider, and I have a horizontal asymptote at 2, but all I need to do is just change that D, and the horizontal asymptote moves as well. Now, when it says, well, okay, what does the value of D kind of mean? Well, I guess we could say, there's a lot of things we could say, but maybe if D is positive, what does that say about the HA? Well, the HA is located where in relation to the x-axis? Above. And of course, if D is less than 0, we notice that the horizontal asymptote is below the x-axis. All right, so we got that chart filled out. Okay, now we are going to move to the next page. And this is where, unfortunately, we're going to have to do a little flipping back and forth. Because it says in this particular page, we are going to refer back to the 12 exponential functions that were found on one of our previous pages. For my students, these were the 12 cards that we had in class yesterday. And we're going to complete the following table. But you guys, for the purpose of class and this video, I'm not going to complete all 12 rows. Okay? Now, for you guys in here, you know that there is no homework with 14.2, right? Can we get a cheer about that, right? You were happy when I said that? All right, that's right. Okay. Now don't cheer too much, because what little homework there will be, it would be for you to finish what parts of the notes that we don't complete. Okay, but there will be no Schoology submission. So let's do, I think I'm going to do a total of 4 or 5 of these rows. So we'll do row 1. Now, row 1 means that we're going to refer back to our first graph. But let's first of all address the first question. It says, does the graph of this function, number 1, increase or decrease from the left to the right? So we go back to, we go back to card number 1, and you can easily tell by just looking at the graph, does this increase or decrease, you guys? It increases. So we are going to write the word increase, of course. Pretty easy. Now, without even going back to the graph, what would you say about the second question? Classify this as growth or decay. You would say growth, right? And I agree with that, because that's what increasing really means. We are growing. Now, if I ask you the second or the third question, based on the equation, has there been either an x or a y-axis reflection? Now, I may have to take you back to the graph or the equation. Looking at this equation, is there an x or a y-axis reflection? And the answer is no. And the reason is because you don't see a negative either in front of the base or in front of the x. And again, I know you guys might sit there and think, what's the big deal about that? It's coming up. So we just say no here. And then we answer the last question, which is probably the easiest of the four. Is the b value greater than 1, or is it a fractional value between 0 and 1 in this equation form? Remember, b is the base. So I go back, we look at our b, which is 2. Pretty easy to see that 2 is bigger than 1. So we're going to write this. b is bigger than 1. Okay? And based on our conversation yesterday, you guys were thinking, of course we're going to grow because b is a number bigger than 1. That causes growth. Not so fast. Let's jump down to number 7, which, by the way, your homework for tonight will be to do 2 through 6. That's the first part of your homework. Okay? How long will that take? 15 seconds, maybe? Okay. All right. That'll be pretty quick, you guys. All right. Now let's look at number 7. So I know, again, you can flip, or if you don't want to flip in my class, you can just look up at the screen. Is this graph increasing or decreasing as you go from left to right? Decreasing. So we'll write the word decreasing in number 7. Without even looking back at the graph, is that growth or decay? It's decay, right? There's no trick to that. Decreasing is always going to be decay. Okay, guys, talk to me about reflections. Does number 7 have any kind of reflection? Oh, there's a negative in front of the exponent. So what kind of reflection is that? Y-axis. Remember, the exponent negative is y-axis. Out in front with a negative is x-axis. So we write y-axis symmetry. And then the final question I ask is, what is the value of b? Is it bigger than 1 or not? Well, we go back to number 7. Again, I apologize for the scrolling. But the b value is 2. Pretty sure that 2 is bigger than 1. So we write b is bigger than 1. And what happens? What do we think? Well, we think we made a mistake, right? How can b greater than 1 be decay? It's because there's a reflection. And one reflection changes it sort of to the opposite of what you would normally think. Okay? All it takes is one of the two reflections to make a positive b result in decay and not growth like we originally thought. All right? Let's do another one. How about, let's just go ahead and do 8. Let's do 8. So we're going to look at the graph of 8, and we notice that this graph is certainly increasing from the left to the right. And while we're on the topic of increasing, we know that this graph does what? Growth or decay? Yep, growth. So you'll write increasing and growth right here. Very good. Now, I don't know about you, but I have already forgotten what the equation looked like, so I can't answer the reflective stuff until I look back at it. So we'll look back at number 8, and I see that there is a negative out in front, so that means there's what kind of symmetry? X-axis. Is there a negative also with the x in the power? No. So we only have x-axis symmetry. So we fill that in. And then one last time, I'll flip back and let's find the b value. Looks like the b value is 1/2. Pretty sure that 1/2 is less than 1. You guys agree? So this is what we want to write there, right? Because if the question says, is b greater than 1 or is 0 less than b less than 1? So our options are either one of those two things, okay? Now again, isn't that sort of counterintuitive? A b value that's a fraction less than 1, you guys normally would think that that's decay, but it's actually growth. Why? Because we had one reflective property going on. Okay? All right. Guess what the rest of your homework is on this page? Do 9 through 12. That might take another 20 seconds or so. All right? Now let's move on to this part. Now this part looks a little scary, doesn't it? Oh my gosh, look at all those blanks. I'm going to streamline this for you a little bit. It says, after completing the table on the previous page, and I know you're thinking, well, wait a minute, Mr. Record, I haven't completed the table yet. We've only done 3 of them. You're a smart group. I think you guys can still figure this out. It says you should now be able to make 4 preliminary inferences as to how to determine, based solely on the equation, if an exponential function will have graphs that represent growth or a decay. It says make those inferences below. And you guys, there's a lot of things that ride on this. So I'm going to help you out a little bit. These can be organized in any way that we want, but I want us to try to organize them all in a similar fashion, because if I ever refer to inference number 1, we'll all have the same thing on our handout. So let's talk about if b is a positive number, greater than, I'm sorry, if b is a number greater than 1, right? B has to be positive, but if b is bigger than 1. Now, before, we would just simply write that off as being, oh, that's growth, right? That's always growth. Well, is it? Well, some other things have to be true. Let's say that b is greater than 1, but at the same time, let's say that the a value was positive, and let's say that the x value was positive. Now remember what we have, and I'm going to write the function here. This was the general form, right? This is the general form of an exponential function. Am I right? Now I think I should probably modify this a little bit because there could be a horizontal shift. So I think we had this minus c built in, if I'm not mistaken. Okay? That was the general form that we saw earlier, right? Now, if all of those things are true, what's going to happen? This should give us what kind of a behavior? Growth or decay? It should be growth, right? Question, Alex? Well, that would, I guess, be positive. I don't know how often you'll see this, but are you thinking something like this, maybe? Let's write like a real general. This is a pretty crazy one, but it could be. So you're thinking like that? That's a good point. If this were, I would call this a positive in front. Okay? But if you solve this equation instead, let's say, Alex, it looked like this, then we're going to treat that as one negative. Okay. Well, I see what you're saying. I think I see what the confusion is. If we go back to what was it? It was the first page, right? When we were analyzing these things. See, this is where I want to be careful because see, when I solved for c, I got 2. Don't confuse c and x, in other words. Or don't confuse like what we have up here. You're looking for a sign in front of the x, and that's it. It doesn't matter what the c sign is, if the c has a minus in front of it or a positive. Am I still not answering? Okay. Okay, but x won't be a number though. That's the thing. X is going to be the variable x. So if so you're always going to have a form that has the variable x here. The question is there a negative in front of it or is there not a negative in front of it? So I see what you're saying. When I write this x here, I want you to always assume that value of x is positive. I tell you what, maybe we can do this. And I understand why you're confused. I think maybe I'm a little confused by it as well. We could say if a is positive, and then we'll say a positive in front of x. Does that help? Is that a little bit more clear? Okay, let's do that. I'm going to be honest. I was reluctant to write that, and I wanted to, but I didn't think that you would like it because it was more wordy. But I think it's definitely going to be clearer. Okay, so we'll say a positive in front of the x. That means we have growth. All right? On the other hand, let's say that if we have b that's less than 1. Okay, now b is less than 1. Now what does that really mean if b is less than 1? Well, maybe I should say it like this. B is going to be between 0 and 1 because b can't be negative. And b can't equal 1. We've already established that. Okay, now if that's the case, and at the same time the a is positive, and we have a positive in front of x. What does that mean, you guys? If b is less than 1, then we have decay. Right? That's like the main topic yesterday. But now, all of a sudden, there are some curveballs handed to us. Okay? For 3, let's say that b is greater than 1. Okay, looks like we might have growth, right? But something has happened. Let's say the a is negative, and this is a very important word, or, and I'm going to underline it. So that means one or the other is true. Either a is negative, or there is a negative sign in front of x. One of those two things is true. Do you guys think that this is growth or decay? It's decay, exactly. It's decay. Now, if you're a little reluctant, you're like, I don't know if I believe that. All we have to do is just really quickly go back to the graph here and say, all right, here's my graph. Let's see. I forgot what b was. It's been a long time, so I go into the function, and how come? There it is. And I see that, oh, yeah, my b is greater than 1. It's 2, in fact, right? But I'm going to make either the a negative or the x have a negative in front. Well, it's a lot easier for me with the sliders to make the a negative. There it is, and I do have decay. Now, if the a was positive, right, I have growth, but not if I make the x have a negative sign in front of it. Then it's going to turn back to decay. You see how it decreases. Okay? Now let's move this back to a positive because that's what I wanted it to be in the first place. Okay, now do you understand that there's another way to think about this? What if b was between 0 and 1? Which means you would think that you would have decay, but at the same time, either a was negative or there was a negative in front of x. Then what do you have, you guys? you have growth. Even though you have that fractional value of b less than 1. Okay, now 4 is the one that's really interesting. Let's say in case 4 that the b is positive again. Looks like growth, right? But you know what's going to happen now? We're going to change the word or to and. So both the a is negative and we have a negative in front of x. Any predictions? Anybody want to be brave? I think I heard it. What is it? You guys, it is growth. Okay. Do you want to see a graphical representation? Let's look at it. So I guess I need to change both this x to have a negative in front and make this a negative. There it is. Is that growth? When our b is a number bigger than 1. Okay. Hey, while we're on the topic, let's go ahead and do this. Let's change this b to not be greater than 1. And the easiest way for me to do that is to put a decimal in front of it, right? What do you think this is going to be? Decay. So do you see that if it has both kinds of reflective nature, they like cancel each other out? Okay. That's pretty tricky, guys. There's a lot of information here, but I think by kind of combing over it very slowly, you won't be tricked by this. So here are the last few things that we have to write. That's a D, everybody. So if a is negative and we have a negative in front of x, then that means we have decay. And the good news, there's no other possibility, right? Your problems are always going to fit into one of these. Truly, it's really 6 different options, right? Okay. Now, I want you to cross this off because it asked, what is the only scenario not included? I just included it because I want to make our job a little bit easier, okay? Obviously, there was only supposed to be 4 possibilities here, and I threw in the other 2. This is a very easy set of boxes to include, and we are going to do 1 and 2 together, and you guys are going to do number 3 for homework. So it says we have a function, all right, and it asks you, is the value of b greater than 1, or is it between 0 and 1? What do you guys say? Well, it's a no-brainer, right? 2/3 is between 0 and 1, so we just write it underneath. Here's a simple question. I need a number. How many reflections are indicated in this equation? 2, right? As evidenced by the negative sign in front and the negative in front of the x. Okay, now what? It says sketch the graph. How are you supposed to sketch this graph? Well, you can't sketch the graph unless you use technology. So I'm going to go ahead and run that sketch here through for you if you don't mind. So now I'm going to go actually into a document, and we're going to go ahead and sketch this. Negative fraction value of 2/3 raised to the negative x plus 2 plus 3. Are you ready for it? You guys excited? I can tell. There's the graph. Now, when it says to sketch the graph, I don't want a 100% perfect rendition of this. All I want is something that's got the general shape. So what you could do is, I could kind of pull this aside like this, just so that we can see it temporarily. All I want is this. Just sketch an XY axis. I'm going to change colors to make it stand out. And just draw something that sort of, kind of, maybe resembles the shape of the curve, and that will do it. Okay? We're going to worry so much about details later. Okay, so I can get rid of this. All right, simple question. Is this growth or decay? Let's look at the graph. It's decay, right? Now, if you look back at the B value, which of course was 2/3, isn't that what we kind of thought would be the case? Whoops. We kind of thought that that was going to be decay. And the reason is because it has the 2 reflections. Does that make sense? It's like the 2 reflections will cancel each other out. And that's what you're going to see in 2 and 3. All right? In fact, you guys, I'm going to have you all do 2 and 3 for homework. All right? We don't have much homework here with this, right? We got to give you something. Now, the next page says, how might you rethink your 4 inferences? Well, we don't need to rethink anything, you guys, because I've altered the notes a little bit so that we have all 6 possibilities. And to be honest, I did that a little bit with the interest of time in heart, in mind, and I'm not proud of it, because it would have been a lot more powerful, I think, if you guys would have gotten together and made these inferences. But with all of your sophomore classmates away taking I-STEP, that was a little bit tough to do with just a small group today. All right, so we're getting down to the finale here. I know there's still a couple more pages to talk about, but there's not very many problems. So in this section, it says, just simply determine if the following functions are examples of growth or decay, but state the reasons that lead to your conclusion. And then they also want you to state the equation of the horizontal asymptote, because we haven't done that much. Now, this is very likely the kind of problem that you are going to encounter. Okay? So what you're going to have to do with this is make sure that you're justifying these in the most appropriate manner possible. Okay? So, for number 1, it says, if f of x is -2 to the x plus 3, is this going to be growth or decay? Can somebody get the door for me? Thank you. Is this going to be growth or decay? What do you guys think? Well, initially, you look at the 2, and you say that b is greater than 1, so your mind wants to say growth, but because you have 1 reflection, that means it changes it to the opposite. So on your test or your quiz or whatever, you guys would want to say that this is decay. Now, I'm going to ask you for a reason. And the reason is going to be because the b value is greater than 1, which would have meant growth, but, and now you can say this a variety of ways. If you said that a was less than 0, I would be okay with it. Or you could say the function undergoes 1 reflection. I would take that. The function undergoes a single reflection. All right? That takes care of the reasoning behind the decay or growth. Okay? Can anybody in the room tell me what the equation of the horizontal asymptote is? Good. And you didn't even see the lesson. Good. Y = 3. Good. That's going to be one of the easiest things, right? Just figuring out what that value is and just putting a y equal in front of it. Okay? Really quickly, let's do 2 together, and then we're going to call it a day. What's the value of b? Ooh, it's less than 1, right? It's between 0 and 1. Normally, you guys would say that's going to be decay, right? But what's the actual answer? growth. What? Yeah, it's growth because although our b is less than 1, what kind of reflection do we have, or how many reflections do we have? Yeah, the function undergoes 1 reflection. Now, if you say this, the function undergoes, what kind of reflection is this? Y-axis. It undergoes a y-axis reflection. That would be okay. The only problem with that, though, if you said x-axis reflection, that would be wrong, and you would lose a point. So it could be safer if you said the function undergoes a single reflection. Okay? Real quickly, without justifying it, is h growth or decay? Growth, because it has 2 reflections. And those of you who just came in, I know you're like, what? What's 1 reflection versus 2 reflections? If you watch this video that we just made, it will be crystal clear. I think everybody would agree, the freshmen, we went very slowly through this. Okay? So everybody, the sophomores, freshmen, I'm sorry, your homework is to finish up problem 3. And then I would like you to try to do the remaining portion of this as much as you can, but I'm going to kind of fill in the gap with this when we meet tomorrow, when we meet back again on Friday. Okay, for everyone watching the video, thanks for being around, and we're going to go ahead and probably broadcast a short video that takes care of the rest of this lesson. But anyhow, we'll see you next time.